Alright, in this video we're going to find the Taylor series of this rational complex function. In the first instance, want the series in powers of z. The second instance, want the series in powers of z plus 1. And then in each case, we're going to want to specify the region in which the series is convergent. Okay, we might want to think of finding this using the traditional root of repeated derivatives, but I think after the first derivative we quickly notice that working this out using the root of repeated differentiations, it's going to be pretty prohibitive, because you can see that from here onwards we're now going to have to use the quotient rule. So we're going to see if we can work this out using another root. Well, as it turns out, the denominator here we can factorize, so we're going to make the best make use of that. So the denominator, if we write 2z here and z there, the constant is 5. Put 5 here, 2z times 5 is 10. Then if we put minus 1 here, that works out to this. So we can factorize that denominator. That means we can resolve these into partial fractions, which are then going to be easier to handle than that composite fraction. Right, if we clear the denominators here, we're going to have 11 is equal to a into z plus 5 b into 2z minus 1. So then we're going to use the roots of the denominator. 1/2 is one of them. So when z is 1/2, the left hand side still 11. Right hand side, this one is going to be 5.5, which is 11 over 2. This one vanishes. So this is telling us that a is going to be equal to 2. Out of the root is -5. Left hand side is going to be 11. This term vanishes. This one is going to be -11. So this tells us that b is going to be -1. So f of z, therefore, we can write as 2 over 2z minus 1 minus 1 over z plus 5. Now, these are much easier to handle, even if we had to use repeated differentiations, which of course we will not. Okay, so from here, the way we're going to proceed is we're going to use the geometric series result, which says that 1 over 1 minus w is the summation of w to the power n, and this is going to be convergent so long as the magnitude of w is less than 1. So we're going to want to write each of these in this form, and so this is how this is going to go. The first one, if we simply write the two terms in, we're going to multiply both numerator and denominator by -1, then we can see that this is going to be our w. The second one, if we factor out 1 over 5, then we can write this as 1 minus -z over 5, and so this is going to be our w. So from then, this is simply going to be the summation of 2z to the power n, and Just one moment, I think there's a minus there, so this should be minus here and minus there. So going to be the summation of negative z over 5 to the power n. Okay, now we've already mentioned that as soon as we write this in summation notation, it is good practice just to write the convergence conditions. So that's for the first one, where we say w is to z. The second one, w is negative z over 5. So that's going to be the convergence condition. Now, simplifying this further, what we are going to do is we can combine them into just one summation. Here we're going to have negative 1 over 5 to the power n, negative 1 over 5 there. So that's just going to give us negative 1 over 5 to the power n plus 1. Then here we're going to have 2 to the power n times 2. So that's going to be 2 to the power n plus 1. And then everything is multiplied by z to the power n. So that is going to be our Taylor series. So this is centered at the origin. I already mentioned that the question says in powers of z. So if you take this and equate it to 0 and solve, then that gives you the point where the sequence or the series is centered. Now, for the radius of convergence, we have got two conditions. Got this one and this one. So we need to sort them and then find the intersection region. So for the first one, this is going to give us mod z is less than half. For the second one, this is going to give us mod z is less than 5. So clearly this is going to be a bigger disk than this one. So first one is mod z is less than 1/2. The second one, mod z is less than 5. So the region of intersection is going to be this one. So that means our region of convergence is going to be mod z is less than 1/2. The other way of confirming this, of course, is coming here and looking at our singularities. So you're going to notice that f is going to be singular when z is 1/2, because this denominator vanishes, and z is also going to be singular when f is going to be singular when z is -5. So those are the two singularities. Now we are doing the expansion about z equal to 0. So 1/2 is going to be around about here, and then -5 is going to be there. So the closest one to the point about which we're expanding is 1/2, and this is agreeing with what we already found there. Okay, so that is sorting out part A. Now I'm going to go to part B. So in part B, want the Taylor series of this in powers of z plus 1. We already said equate this to 0 and solve that. That gives you the point about which the Taylor series is expanded. So here I want Taylor series about z equals to -1. What we are going to do, we've already shown this in the previous video, is we let u be equal to z plus 1, and then do a Taylor series about u equal to 0. and then rewrite things in terms of z. So from here it means that z is u minus 1, and so if we write f of z in terms of u, 2z minus 1 here, z plus 5, so this thing is going to be 2 over u minus 1, take away 1 over u minus 1 plus 5. So this is going to be 2 over 2u minus 3. This is going to be u plus 4. And then we just want to do the Taylor series of this about u is equal to 0. So so again, if we here factor out 2/3, make it negative 2/3, then there's going to be 1 minus 2u over 3. Here, if we factor out 1 on 4, then this is going to be 1 minus negative u on 4. Then after that, this is negative 2/3. It's going to be summation of 2u over 3 to the power n, and then minus 1 over 4. That's going to be summation of negative u over 4 to the power n. And then, as we mentioned before, let's just write out the convergence conditions. So for this one, let's write them this side. Gonna have 2u over 3 less than 1, and then from this one, magnitude of this is less than 1. Okay, but for now, let's continue with the simplifying. So here we're gonna have negative 2 over 3, summation of 2 over 3 to the power n, minus 1 over 4, negative 1 over 4 to the power n. And then after this, we can combine these into one summation term. Negative 1 over 4 is going to be to the power n plus 1. Then 2 over 3 to the power n plus 1 as well. And then this is multiplied by u to the power n. Then writing this in terms of z, so this simply gives us negative 1 over 4 to the power n plus 1 minus 2/3 to the power n plus 1. Now u is z plus 1. So z plus 1 here to the power n. So that is going to be the Taylor series for this f of z. And then when it comes to the region of convergence, so we've got 2u over 3 less than 1, which gives us u is less than 3/2. U is z plus 1, so that's a mod of z plus 1 is less than 3/2. Then the other one, we've got negative u over 3 less than 1, so u is less than 3, so that gives us mod of z plus 1 is less than 3. So obviously this is bigger than this one, so we expect that this is going to be the intersection region. Let's just do a sketch so that these are both going to be centered at -1. So this is -1 here. The first one, the radius is 1.5, so it's going to look something like this. Then the second one, the radius is 3, which is twice of 1.5. It's going to look something like this. So we expect that this is going to be the region of convergence. We can do this geometrically again. So we say this one is centered at -1. So here we have a diagram where we already have the two singularities. So if this is half, this is -half, so -1 is going to be there. So again, the closest is going to be this one, and the distance from here to there is going to be 1.5 or 3/2. So that's why we are going to have this as our region of convergence. All right, at this point we are going to give you a similar problem to work through. So what you can do is to pause the video, work through it, and then compare with our solutions when you continue the video. All right, so I would like you to have a go at finding the Taylor series of this rational function here, first in powers of z, then in powers of z minus 1, and then in each case you are going to work out the region of convergence. Right, so if you just pause the video, have a go at this, and then when you continue the video you can compare with our solution. All right, we're now going to scroll down to our solution for this question. While we do that, we'd like to thank you for visiting our channel and watching this video. We do hope that the material is helpful to you. We do implore you to subscribe to our channel so that you can support us, and then we can be in a position to make videos like these ones. If you have got questions or comments, you can just post them in the comment section below. So for this question here, if we factorize the denominator and it works out like this in terms of if we resolve it in partial fractions. So if we write it in the form 1 over 1 plus 1 minus w, the first fraction and the second fraction work like that. And so these are going to be the two summations with the corresponding regions of convergence. And then simplifying, we can write it like that. Now, between these two, this one is going to be the intersection because it's a smaller one. So it's a disk of radius half centered at the origin. For the second case, if we let u be z minus 1, then our function is going to be 2 over 2u plus 3 plus 1 over u minus 1. We factor out 3 in the denominator here, and just negate both numerator and denominator here. Then this is just our geometric series, and similarly here. Now here, these two we can combine provided there is a negative here. So what we do is we put a negative, but then we need another negative. So then this times this is -2 over 3 to the power n plus 1. But then there is this other negative which we have outside here. This is just going to be 1 there. And then the region of convergence is going to be centered at 1. So one of them is radius 3/2, the other one is radius 1. So the one with radius 1 is going to be this radius of convergence, which is the intersection between the two. Thank you.